Hey there, compressed air friends. So, I was doing a little troubleshooting on this here air compressor today, and I thought, why not shed a little light on a control system that is out of date, yeah, but there's still plenty of them out there, and these things are still the bane of many a service tech's existence. And so, I just want to step through this real quick. Tell you guys a little bit about my troubleshooting process on here, and share some documentation and stuff with you guys that might be extremely helpful. So this is an old Gardner Denver Saver machine. It has the TS Plus controller, and this is the one that has your inlet valve closed, inlet valve open, and blowdown solenoids. And these Gardner Denvers are a little bit different than most machines in that we have this 3-solenoid setup, and they even unload a little bit differently as well. So what you're up against here is when a Gardner Denver machine initially unloads, it unloads differently than other machines in that it simply closes the inlet valve. You know what I'm saying? You know what I'm talking about. It closes the inlet valve. You know what I'm saying? Anyway, yeah, it just closes the inlet. It just closes the inlet valve. It does not open the blowdown valve, and it will run with that inlet valve closed and the sump still pressurized for a determined amount of time. And then once that amount of time has elapsed, usually like 5 minutes, then it goes into what I would call a normal blowdown phase, where it opens the blowdown valve. So now we have inlet valve closed, blowdown valve open, sump depressurizes, and then it continues to run that way for a predetermined amount of time, usually 5 to 10 minutes. And then it will, like a normal air compressor, shut off, go into standby. And then we have this setup here. And what we've got here basically is, so over here we've got our air feeding into the system. We have a shuttle valve here. One side of this runs down to the sump. The other one runs over to the hot side of the minimum pressure check valve. And just depending on whichever side has greater pressure, whether it's the line or the sump, that's what's going to supply your air to these control components. Then you have your regulator. You can see I was doing some testing, so mine's kind of back down. Let's get him up. About 22 to 25 psi is all the more you want that regulator to be. Any more than that, you're going to blow diaphragms out. Any less than that, your control system is just not going to work. So we have our inlet valve closed solenoid, we have our inlet valve open solenoid, and we have our blowdown valve. And just as you would suspect, the job of this solenoid valve is to put an air signal to the inlet valve to tell it to close. The job of this inlet valve is to put an air signal to the inlet valve to tell it to open. And the job of the blowdown valve is to evacuate the pressure from the sump. So this particular machine will run, it starts, it runs, but it does not load. And one of the best troubleshooting tools I have for these machines, because I'll be 100% honest with you guys, I have not had enough exposure to these control systems from a troubleshooting standpoint to be able to just fly in here and go, there it is. This beautiful Solaire LS90 right next to me here. That guy I can fly in and troubleshoot no problem. This guy, we don't need some help. So that is where, bear with me a moment. So that's where these come into play. These color-coded PNIDs are a lifesaver. So I have one of these for every phase of how this compressor runs. So right now we are looking at the fully loaded phase. I have one that shows me unloaded. I have one that shows me blowdown. I have one that shows me modulating. And so basically all I did was I looked over here at the P&I and I said, okay, looking at this, when this machine is running at full load, I should have control air pressure up to my inlet valve close solenoid right here. And then after that, the line turns green, and that should be atmospheric pressure or exhausting. So basically this entire control line, all the way over to this inlet valve purge control, all this should all be venting to atmosphere when this machine is fully loaded. Also, the nice thing it tells you is that in the fully loaded state, these should all be energized, meaning you should have power to them. So what I did, based on the information from my P&ID, was I got this air compressor running, and I came over to right here, this line right here, which on our P&ID is this line right here. And the first thing I did was I backed that regulator all the way down as low as it would go, which is like 10 psi, just to make sure I'm not, I'm only dealing with as much pressure as I have to deal with. Now the interesting thing that really got me thinking was, as soon as I backed that regulator down to 10 psi, I got a little bit more sump pressure out of this thing. So I said, okay, that's interesting. So then I came over here and I removed this line. Just took my wrench, ripped the thing right off of there. I still had air coming out of this line, and when I removed it, the machine went to full load. Started, sump pressure pressurized. You actually heard the machine kick up. So I said, okay, this is still giving me air when it should not be giving me air. So I hooked it back up, and I went back over to my P&ID over here, and I said, okay, I have air here. I should not have air here. So if my IVO was malfunctioning, it shouldn't make any difference, because my IVC is what is responsible for killing this airline right here. So I said, okay, obviously I'm still getting air through my IVC, and why would that be? Well, looking at my P&I, I said, oh, those should be energized. So I got my arc flash gear on, and I jumped into the cabinet, and I pulled up a wiring diagram on the handy dandy iFix compressors app, which actually has the manual for this ES Plus controller in it if you have the database downloaded, which has a wiring diagram in it. So I looked at my handy dandy wiring diagram, and I said, oh, all three of these solenoids right here are terminals 11, 12, and 13. So I checked for power on terminals 11, 12, and 13, which I had. So, back over here. So, it would stand to reason I'm getting power to this solenoid, which is supposed to be canceling that air signal, but yet I still have an air signal out of here that I should not have. So, survey says we have a bad inlet valve close solenoid. Now, unfortunately, this is not one of the many parts that my customer stocks, so I'm going to have to order this for them and come back, put it on, blah, blah, blah. But, like I said, this guy right here is absolutely invaluable. And if we pull up, so this is compressor unloaded. And once again, it's all color-coded and shows you exactly what's going on. So when we are unloaded, all three solenoids are de-energized. You now have control air coming through here, over to that, and to the inlet valve to unload it. Shows us our sump should be at atmospheric pressure. All these lines should be at atmospheric pressure. Showing us our blowdown valve right here, open, and that runs over there. We go go back. Come on. iPad, knock it off. If we go to, like, I think it's this one. Yeah. So yeah, this is unloading, but not blowing down the sump. So once again, you can see we have that control air coming through here to the inlet valve to tell it to close. But our blowdown valve right here is closed. And obviously this is all going to be open to atmosphere, but our blowdown valve here is closed, not allowing that sump to blow down. So, like I said, man, these things, when I have to troubleshoot one of these old Saver systems like this, these are absolutely invaluable to me. If you need them, if you want them, let me know. I will send them to you. Shoot me a DM or something. I have no problem sending these over to anybody that needs them. Otherwise, they are in the books. If you still have any of the old books for these machines, they are in there. I just basically snap pictures of them and save them as a separate file on my iPad so that they were available to me anytime I needed them. So that's what we got today, friends. Have a good one.